Well, hello, my physics distance learners. Just a quick video. I've got a couple just to go over the math for chapters 34 and 35. They're probably the most mathy of these electricity and magnetism chapters that we're doing here as our last unit for the year. But what we're going to do in this video is just look at Ohm's law. Then we'll take a couple of looks at what to do if we have a circuit that has series resistors, circuit that has parallel resistors, and then we'll look at breaking down a circuit and determining what the equivalent resistance is inside of the circuit. And we kind of talked about it in the notes, but I just want to make sure we went through it a little more thoroughly so you weren't kind of lost. And then also there's some big differences in what happens with voltage and current in a series circuit versus a parallel circuit. So Ohm's law, a relatively easy law to deal with, is given up here on the board. It helps us figure out what the electric potential or voltage of a circuit would be, the current in the circuit, or the resistance. And with this type of problem, you'd have to be given two. Okay. Once given two of them, you should be able to solve any of the other ones. So basically, what we're looking at here is just a couple of mathematical manipulations to get to the other places. But I prefer Ohm's law as given by V equals IR. There's three different versions. I'm going to go through each of them here very shortly. But they all, again, deal with the electric potential, which is also known as the voltage. It's given to us in units of volts. Amps or current is the I. Why did they choose I? They ran out of letters. Okay, C wouldn't work. It was already coulombs. It's I don't know. So anyway, I is current, and then R is resistance, and its unit is the ohm. So if we have V equals IR, but this is good for solving for V. Okay, if you know your math and you can work through it easily, basically given I and R, you multiply them together, you're done. But let's say you were given a problem where you had to find current. Now, personally, I could do it either way, but I always like to find whatever I'm looking for by itself and then plug in what I know at the end so the numbers don't confuse me. So if I wanted to find I, I'd have to divide off R from both sides. And we see then that mathematically this turns into I equals V divided by R. Then given the voltage and the resistance, again, the volts and the ohms, I would be able to solve for the amps or the current. Okay. Now, this is the way the book does it. They give it to you this way initially. I just always learned my Ohm's law is V equals IR, so it's the preferred way that I like to look at it. Why? If I know V equals IR, I don't have to worry about which one's on top, which one's on the bottom. I just know V equals IR, boom, right across. And I know what the equation is. Now, as far as what if I needed to find resistance? So again, V equals IR. If I needed to find resistance, I would divide off I on both sides, and R would be equal to V divided by I. So these are really the three equations that you need to know. Do you need to memorize them all? And my thought on that is if you remember one, you know them all. You can always algebraically manipulate them. So, with that being said, I will leave it to you on whether or not you memorize it or not. But again, if you remember one, you should be able to find all three of them. Now, the other thing that we talked about in chapter 34 is power. And power equals I times V. I prefer to remember it this way because you've got something PIV. P equals IV. You know it. It's all one way, right straight across. You don't have to worry about remembering is V on top, is I on top, because it's all linear. It's all one straight line, and you've got your answer. Now, there are some problems that you're going to run into as far as power is concerned. You might be given resistance. You might be given resistance and voltage, let's say. You might be given um, current and resistance. What at that point is the power. And so at that particular point, what you have to do is, again, some more algebraic manipulations of this P equals IV, but inputting things that you know from Ohm's law. And so if we took V and plugged in IR, well, then we would get P equals I times IR. And so P would be equal to I squared R. So, there is one equation that may be helpful. P equals I squared R. P equals IV. We may also, like I said, know the resistance and know the voltage. In that case, we'd want to plug in, well, what is I? Well, I is V divided by R. So P is equal to I divided by, V divided by R. V divided by R times V. So there's I. And so P then is V squared divided by R. So that would be another valuable equation that you could use to find power given the voltage and the resistance of the circuit. And so anyway, 3 different equations there. Do you have to memorize those 3? This one, it might be a little bit more valuable to memorize those 3 than it is to memorize those. But as long as you know this one and you know this one, you should be able to come in with the parts to fill it in. So again, you would always get the use of a formula sheet. So memorizing isn't a necessary process anyway. But that's kind of my thoughts on chapter 34. And again, we will be looking at some other ones here real quick.